Today we're doing section 3.4, day 3, and again we're still going to be focusing on logarithmic equations. So this is very similar to what we did in yesterday's lesson and what we practiced yesterday. Notice that the difference is in between the two logs I'm now subtracting instead of adding. So when I condense these, I have to condense with division. So I have log base 2 of the quantity of x plus 2 divided by x minus 5 equals 3. And now I put this into exponential form, so that's 2 cubed equals x plus 2 over an x minus 5. And I know 2 cubed is going to become 8. So if I wanted to clear this fraction, I'm going to multiply both sides by this x minus 5 on both sides. So on the left-hand side, I'll get 8x minus 40. On the right-hand side, these would cancel, and I'm left with an x plus 2. So notice this is a linear equation. It is not to the second power, so I will not be doing any factoring, which means I don't want to equal to 0. It means I want to get all my x's on one side and numbers on the other. So I would want to add this 40 over, and I would want to subtract this x over. So I get 7x equals 42. Divide both sides by 7, and we get that x equals 6. And again, all these problems you could do a quick check for. So if I did a quick check, if I plug 6 back in, I'd get log base 2 of 8 minus log base 2 of 1, and I get 3 minus 0, which is 3. And that's how you know it checks out. So for the next one, this is where we're kind of going to move on into the different sets. So the last one we just did is where I had logs but only on one side of the equal sign. Now I have them on both sides of the equal sign. So on the left side I want to condense, and because it's subtraction, I'm going to condense with division. So I have x plus 2 over 4x plus 3, and it's equal to the natural log of 1 over x. So the difference here is when I had log on one side, I put into exponential form. Here, I don't have to do that. Because I have logs on both sides, it's kind of like the same idea of when I had like the same base on both sides. So this is just a random question. Like if you had this, you would drop the 2's and you would just say x equals 5. So it's that kind of same idea. I'm going to drop those natural logs because I had them on both sides and set the insides equal. So x plus 2 is equal to 4x plus 3, or sorry, x plus 2 over 4x plus 3 is equal to 1 over x. So if I wanted to clear the fraction, I'm going to multiply both sides by x. So on the right-hand side, this cancels and I'm equal to 1. On the left-hand side, I have x squared plus 2x over 4x plus 3. And a lot of you on your extra credit that you tried, you were multiplying the top and the bottom by x. This is like an x over 1, so only the top gets multiplied by x. Now to clear the next part of the fraction, I'm going to multiply both sides by the other denominator of 4x plus 3. So this is going to cancel, and I'm left with x squared plus 2x equals 4x plus 3. Now this is a problem that is a squared, and when it's squared that means I have to factor. So in order to factor I need this equal to 0. So I'm going to subtract 4x over, and I'm subtracting 3 over. So I'm dealing with an x squared minus 2x minus 3. And because the leading coefficient is 1, I don't really need to do the whole process of factoring. I can just fill in the values. So this is going to be an x minus 3 and an x plus 1. And again, you can only do that when the leading coefficient's 1. So the two answers we get are 3 and a negative 1. If you don't like just filling it in, you can still do the normal factoring. You're looking for what multiplies to be negative 3 and adds to be negative 2. As far as the check goes, when I plug in negative 1 into this quantity over here, I'm going to get 1 divided by negative 1, which is the natural log of negative 1. And we know we can't do that. So the negative 1 answer gets tossed out because I would get an undefined answer So x equals 3 is our only solution to this problem. So one more, again, I have logs on both sides, but this one's a little bit different. So notice on the left-hand side I have the 3 out front, and I know when I have a 3 out front that came from an exponent. So I'm going to send it back to being an exponent. So that means this was x plus 4 to the 3rd power. On the right side, we do a little bit of evaluating. I know log base 2 of 4 is equal to 2. So I have this log base 2 of an x plus 4 cubed is equal to 3. So now I want to put this in exponential form because it's not like the last problem. So it temporarily looked like it was going to be the same as the last problem because I had logs on both sides, but it actually turns into a log on one side, and that's where I would put it in exponential form. So I have 2 cubed equals x plus 4 cubed. And if I wanted to solve from here, I would get rid of this cube root of the cube by taking the cube root of both sides. So both of those cubes are going to be canceling with that cube root, so that means I have 2 equals x plus 4. And then I subtract 4, and I get x equals negative 2. Now, we do have to check this one, so don't think that all negative answers get tossed out automatically. If I did the check, I'd have 3 log base 2. So negative 2 plus 4 is a positive 2. I know log base 2 of 2 is 1, so 3 times 1 is 3. And notice on the right-hand side I had 3. So this checks even though it was a negative answer. So that's all for today. We're going to pick up with more practice on this tomorrow.